Okay, now let's look at the problem number 41. An object moves with constant acceleration 4 meters per second squared and over a time interval reaches a final velocity of 12 meters per second. If its initial velocity is 6 meters per second, what is its displacement during time interval? What it is a distance it travels during this interval? So let's first solve the part A and B. Okay, so the given values is actually the acceleration, which is equal to 4 meters per second squared. Then we have final velocity, which is 12 meters per second. And if initial velocity is 6 meters per second, then we have to find a total we have to find a displacement, and also, so in the part A we have to find delta x, and in part B we have to find a total distance. Now, before solving such a problem, we have to understand a couple of things. The first of all, as you can see here, our initial velocity and final velocities are positive. Moreover, we can see that initial final velocity is greater than initial velocity. So that means when the direction of velocity is in the same direction of acceleration, then your velocity will keep increasing. Okay, as time goes, your velocity will keep increasing. But if your velocity, suppose, is in a negative direction, but however your acceleration is in positive direction, then what happens? Your velocity, that object is moving to the left side, since it's negative, so it's on the left side, so object will start slowing down its speed or its velocity. At some point it will stop, which means if it has some initial velocity here, but it's negative because it's moving to the left side, then at final velocity it will stop. Why? Because your acceleration is pointing in opposite direction. Okay, it stops here and then it starts gaining the velocity, but in an opposite direction, which is in the same direction as in acceleration. Okay, now let's solve this problem. So let's find first of all displacement. In order to find the displacement, we have a formula which is v final squared is equal v initial squared plus 2a delta x. Now from here we can find our delta x, which is equal v final squared minus v initial squared divided by the 2a. If you plug the numbers, so v final in our case is 12 squared minus 6 squared divided by 2 times 4. If you do calculation, then you will find that your displacement is equal to 13.5 meters. Now what about the distance, total distance? Now, since we know that when v velocity is in the same direction as an acceleration, then we can say that our delta x is equal to the d. Okay, now this is a part A, B. Now what about part C and D? Let me write down here. Okay, in the part C, if its initial velocity v initial is equal to minus 6 meter per second, if it's minus 6 per meter per second, then what is displacement during the time interval? Okay, so first of all, let's look at it, what's happening here. Again, initial velocity was pointing to the negative direction, which is 6 meter per second, right? then we know that our acceleration is in a positive direction. We also know that our final velocity, which is equal to 12 meters per second, is also in a positive x direction. Okay, so then what will happen is basically the object that is moving to the left, it will slow down its speed. At some point it will stop. Okay, it will stop, which means at this point v final becomes 0. Then it stops and then it reverses its direction. Okay, it reverses its direction and it will start moving to the right side. Why? Because our acceleration is pointing to the positive x direction. Okay, now let's find our displacement. Since we know that our displacement is only x final and minus x initial. Okay, we're only interested in x final and minus x initial. So by formula we can find that delta x, which is the same formula which we used previously, v final squared minus v initial squared divided by 2a. Now let's plug the numbers. V final was 12 meter per second squared minus, here minus 6 meter per second, sorry, I don't need to write it down, squared divided by 2 multiplied 4 meter per second squared, which is acceleration. If you do calculation, you should get the same number, which is 13.5 meters. Okay, this is our displacement. But however, the distance, or in other words, total distance which is traveled, it will be slightly different here. So let's see how things are varying here. Now, first of all, we know that the initial velocity was in a negative direction. So that means, first of all, we have to find this delta x1. Okay. Now, delta x1 means v final squared minus v initial squared over 2a. We know that since acceleration is positive to the initial velocity, at some point our object will stop, right? So that means when it stops, which means final velocity will be 0. So here we have 0 squared, since this is our v final, 0 because it will stop, minus, then we have here minus 6 meter per second squared divided by 2 multiplied acceleration, which is 4. Now if you do calculation, then you can find that your delta x is equal to minus 4.5 meters. That means the object is traveled to the negative direction, correct? Now then we want to find a total distance. Okay, total distance means the object is started from here, it stopped, and then it went to the certain distance. Okay, so we want to find what is delta x1 and then what is it delta x2, and then we just sum them. Okay, but again, here if you want to find a distance has to be always positive, but displacement can be negative, positive, or 0. Okay, now let's find delta x2. Okay, delta x2. So it stopped when it stopped here, which means here we had another v initial which is equal to 0, right? So that means, but however, our final velocity was 12 meters per second. So final velocity 12 meters per second squared minus 0 squared divided by 2 times 4 meters per second squared. Okay, if you do calculation, you should find that your delta x2 is 12 squared divided by 8. You should get 18 meters per second. So as you can see, it's in positive. So if you want to find total distance that is traveled, you have to take the model of delta x1 plus model of delta x2. Okay, so that means total distance that car is traveled will be 4.5 plus 18. So if you add 4.5, you should get total distance that is traveled 22.5 meters.